out as we go forward. Okay, so I'm recording again. So I had a question about going from Cartesian coordinates to polar coordinates. Okay, I had that question about Cartesian coordinates to polar coordinates. And remember that Cartesian coordinates gives you X and Y, and polar coordinates give you R and theta. Now, the big question is, so if I'm looking at my chart here, this is my X coordinate, this is my Y coordinate, and we're going to go ahead and pick a point here, and we're going to say that this point is -3, and we're at +3. We're just going to go ahead and use an arbitrary point. And if I do that, my polar coordinates are going to look like this. And this is going to be R, but this is the theta. And the question is, how do I get there? And one of the things that you've got to know is you're going to have to figure out which quadrant you're in. So historically, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So the first thing we're going to do is figure out R, right? I can do it a couple of ways, but the easy way is good old Pythagorean theorem, because this is -3 and this is 3. So R is going to be the square root of -3 squared plus 3 squared. So that's going to be the square root of 9 plus 9, which is the square root of 18. And I never was good at doing squares in my head. So this gives us that our R is 2.44. Now, we're going to use our right triangle. And again, this is primarily the trig that you've got to remember. Here's my angle. This is the opposite side. This is the adjacent side. And this is the hypotenuse. So if I just go ahead and use the tangent, because remember that we're going to go ahead and write them out just so that everybody has them. We can actually use the tangent to get there. Because what we have in our triangle, we have, so we're going to actually use the numbers. So the tangent of the angle is going to equal my y over my x. So my angle, if I'm using my points, gives me the tangent, the inverse tangent of 3 divided by -3, or this becomes the inverse tangent of -1. And if I do that and I make sure that I'm in degrees, so I'm going to take my arc tangent of -1, and that gives me, oops, I'm not in degrees. I'm just going, that didn't make any sense. There we go, arc tangent degrees. Try that again. So now I made sure I'm in degrees. And it tells me that this is a negative 45 degrees. So let's go back and look at our picture. What is that negative 45 degrees? What I just calculated was this angle. This is my negative 45 degrees. So the question that I had was, well, what's a good way to do it in one step? There isn't a good way to do it in one step. You have to know by the numbers what my coordinates are and which quadrant I'm going to be in. And then we have to be very careful about what did we just calculate in our angle. Well, if that's negative 45 degrees, we know that this is going to be 180 minus 45 degrees is going to give us a positive 135 degrees. And Blackboard can be kind of, or not Blackboard, but WebAssign can be kind of tricky because it can ask you what is the angle. And remember, this symbol represents angle. What is the angle counterclockwise from the x-axis? And in that case, I'm going to say minus 45 degrees. No, yeah. No, that's clockwise. Sorry. What is the angle clockwise from the x-axis? Or it can ask, what is the angle counterclockwise from the x-axis? And that's going to be our 135 degrees. Yeah, that one's clockwise, not counterclockwise. So they can be pretty persnickety. If I ended up with an angle in this one, and it wanted this angle, it might say, what is the angle below the x-axis? So you do have to pay attention to the terminology. Since we're here, and just because if we start talking about it ahead of time, the question always comes up, and maybe you've never pondered it, but some of us ponder things. So this is my x-axis, this is my y-axis, and the question is, why do we want to look at our angles as rotating it? This is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this becomes 360 degrees. And we are going to take this direction as positive, and that's counterclockwise. We're going to see later on in the semester, and we'll see it a lot as we go through the second semester, is if I put my fingers in the direction of counterclockwise, look where my thumb is. My thumb is coming out of the page. If we went clockwise, my finger would go into the page. And if you think about a screwdriver, righty-tighty, lefty-loosey, right? Lefty-loosey, if I'm turning to the left, I'm coming out of the page, I'm unscrewing the screw and I'm bringing the screw up. If I'm screwing in the screw, I'm going the other direction. And the reason we're going to do that is called the right-hand rule. And that's going to give us a vector direction associated with coming out of the page or going into the page. And we want out of the page being positive. So we're going to see this again, but the reason we do this is because of that. Now, because we're, because our clocks go the other direction, okay? Now, why we do that as 0 and we don't start at Y, I have no idea, because that's just a fact of life as well, but that's what we're doing. So to get back to this, there really is no good way to immediately get which angle I've calculated. So I had a question about the angle, but I'm wondering if I've lost, there we go, we got everybody. It depends on what WebAssign is asking for. Would you keep the angle as a negative, or would you keep the angle as a positive? It depends on what the question is and what the question is you're answering. If I'm doing it mathematically, I would probably just do it this way and I would draw it on my piece of paper. That's why pictures are so important. Pictures are very important in order to keep us going. So what I'm going to do here real quick, first I'm going to stop the recording and then I'm going to start.